So this is question 4 from the Edexcel Corpio Ace Further 2022 paper. This is a roots of polynomials question, and it asks us to work out various things from this quadratic equation. The first thing that you need to notice about this quadratic equation is that there is no x squared term in here. Okay, so when I'm working out my results, and I'm going to write down all of my results to start off with, I need to remember that there's no x squared term. First off, the sum of the roots is equal to minus b over a, so that's minus 5 over 3. Then the sum of the product pairs is equal to c over a. This one is 0 because c is the x squared term and there is no x squared term. The sum of the product triples is equal to minus d over a, which is minus 7 over 3 for this one. And the product of the roots is equal to e over a, which in this case is 6 over 3 over 2. So the first part of this question asks me for the sum of the roots squared. You could work out a formula for this each time, or you can memorize this formula, but the sum of the roots squared is equal to the sum of the roots all squared minus 2 times the sum of the product pairs. Okay. So that works for quadratics, it works for cubics, also works for quartics, so you could work it out each time. The sum of the roots we've got an answer for is minus 5 over 3. The product of the sum of the product pairs is equal to 0 for this one, so we get 25 over 9. The next one is these fractions here. So I'm going to combine these all together. I'm going to factorize out a 2 and then combine these all together. So on the top, you will get the sum of the product triples. So you'll get beta gamma delta plus alpha gamma delta plus alpha beta delta plus alpha beta gamma, which is the sum of the product triples. On the bottom, you'll get the product of the roots. And we've got results for both of these as well. So sum of the product triples is minus 7 over 3. Product of the roots is over 2. That's all times by 2, so I get minus 7 over 3 for this one. Finally, it asks for 3 minus the roots all multiplied together. With all of these, actually, you've got options. So you could have come up with new quartics for each of these. The first one would be very difficult, but you could come up with new quartics, especially for this last one, which has roots related to this, or you could expand this out and use your standard result. So that is what I'm going to do here. So I'm going to expand out these pairs. So I'll get 9 minus 3 times the sum of these, and then plus alpha beta, and same for this other one, I'll get 9 minus 3 times the sum of those, plus the product, and then expand this out again, so I'll get 81 minus 27 times gamma delta, gamma plus delta, plus 9 gamma delta, minus 27 alpha plus beta, plus 9 alpha plus beta, gamma plus delta, minus 3 alpha plus beta, gamma delta, and then plus 9 alpha beta, and minus 3 alpha beta. Gamma plus delta, and then plus alpha beta gamma delta. Bit more expanding and tidying to do. So what we'll get here is we have got 81 for your constant term. Then the sum of your roots, just the singular roots. So we've got this one here and this one here. So we've got minus 27, alpha plus beta plus gamma plus delta. Then your product pairs will have a lot of, so you'll have these ones. So 9 gamma delta, 9 alpha beta. You'll also get some from expanding this bracket in here. So in here, you'll get a 9 alpha gamma, a 9 alpha delta, a 9 beta gamma, a 9 beta delta. That's all of them included in there. So this is plus 9 times the sum of your product pairs. I'm not going to write them all out, but they're all there. You've then got minus 3 times your product triples from here and here. Again, if you were to expand those out, you'll get alpha gamma delta, beta gamma delta, alpha beta gamma, alpha beta delta. So that's all your product triples. It's minus 3 times your sum of your product triples. And then you've got plus your product of your roots. Subbing our results for each of these. So we've got minus b over a for that one. So minus 5 over 3. Then plus 9 times 0 for that one. Minus 3 times minus d over a. So we get 7. That should have been a positive 7 over 3. So should that one, so should that one. And then finally we've got e over a, which is 2. That one. Work this out. 81 plus 45 minus 7 is 121.